Gold is a chemical element with symbol and atomic number 79. In its purest form, it is a bright, slightly reddish-yellow, dense, soft, malleable and ductile metal. Chemically, gold is a transition metal and a group 11 element. It is one of the least reactive chemical elements, and is solid under standard conditions. The metal therefore occurs often in free elemental form, as nuggets or grains, in rocks, in veins and in alluvial deposits. It occurs in a solid solution series with the native element silver, and also naturally alloyed with copper and palladium. Less commonly, it occurs in minerals as gold compounds, often with tellurium. Gold's atomic number of 79 makes it one of the higher atomic number elements that occur naturally in the universe. It is thought to have been produced in supernova nucleosynthesis from the collision of two neutron stars and to have been present in the dust from which the solar system formed. Because the Earth was molten when it was just formed, almost all of the gold present in the early Earth probably sank into the planetary core. Therefore, most of the gold that is present today in the Earth's crust and mantle is thought to have been delivered to Earth later, by asteroid impacts during the late heavy bombardment, about 4 billion years ago. Gold resists attacks by individual acids, but it can be dissolved by aqua regia. The acid mixture causes the formation of a soluble gold tetrachloride anion. Gold metal also dissolves in alkaline solutions of cyanide, which are used in mining and electroplating. It is insoluble in nitric acid, which dissolves silver and base metals, a property that has long been used to refine gold and to confirm the presence of gold in items, giving rise to the term acid test. It dissolves in mercury, though, forming amalgam alloys, but this is not a chemical reaction. This metal has been a valuable and highly sought-after precious metal for coinage, jewelry, and other arts since long before the beginning of recorded history. In the past, a gold standard was often implemented as a monetary policy within and between nations. But gold coins ceased to be minted as a circulating currency in the 1930s, and the world gold standard was finally abandoned for a fiat currency system after 1976. The historical value of gold was rooted in its medium rarity, easy handling and minting, easy smelting, corrosion resistance, distinct color, and non-reactivity to other elements. A total of 183,600 tons of gold is in existence above ground, as of 2014. This is equivalent to 9,513 cubic meters of gold. The world consumption of new gold produced is about 50% in jewelry, 40% in investments, and 10% in industry. Gold's high malleability, ductility, resistance to corrosion and most other chemical reactions, and conductivity of electricity have led to its continued use in corrosion-resistant electrical connectors in all types of computerized devices. Gold is also used in infrared shielding, colored glass production, gold leafing, and tooth restoration. Certain gold salts are still used as anti-inflammatories in medicine. Etymology: gold is cognate with similar words in many Germanic languages, deriving via Proto-Germanic *gulta from Proto-Indo-European *gelh. The symbol O is from the Latin aurum, the Latin word for gold. The Proto-Indo-European ancestor of aurum was *heacutHSO, meaning glow. This word is derived from the same root as *heacutusos, the ancestor of the Latin word aurora, dawn. This etymological relationship is presumably behind the frequent claim in scientific publications that aurum meant shining dawn. Characteristics: gold is the most malleable of all metals. A single gram can be beaten into a sheet of 1 square meter, or an ounce into 300 square feet. Gold leaf can be beaten thin enough to become transparent. The transmitted light appears greenish-blue, because gold strongly reflects yellow and red. Such semi-transparent sheets also strongly reflect infrared light, making them useful as infrared shields in visors of heat-resistant suits. and in sun visors for spacesuits. Gold is a good conductor of heat and electricity and reflects infrared radiation strongly. In addition, gold is very dense. A cubic meter has a mass of 19,300 kg. By comparison, the density of lead is 11,340 kg per cubic meter, and that of the densest element, osmium, is 22,588 plus or minus 15 kg per cubic meter. Chemistry. Gold is unaffected by oxygen at any temperature. Similarly, it does not react with ozone. Gold is strongly attacked by fluorine at dull red heat to form gold fluoride. Powdered gold reacts with chlorine at 180 degrees Celsius to form AuCl3. Gold reacts with bromine at 140 degrees Celsius to form gold bromide, but reacts only very slowly with iodine to form the monoiodide. Gold does not react with sulfur directly, but gold sulfide can be made by passing hydrogen sulfides through a dilute solution of gold chloride or chloruric acid. Gold readily dissolves in mercury at room temperature to form an amalgam, and forms alloys with many other metals at higher temperatures. These alloys can be produced to modify the hardness and other metallurgical properties, to control melting point or to create exotic colors. Gold reacts with potassium, rubidium, cesium, or tetramethylaminium, to form the respective oride salts, containing the O- ion. Cesium oride is perhaps the most famous. Gold is unaffected by most acids. It does not react with hydrofluoric, hydrochloric, hydrobromic, hydriodic, sulfuric, or nitric acid. It does react with aqua regia, a mixture of nitric and hydrochloric acids, and with selenic acid. Gold is similarly unaffected by most bases. It does not react with aqueous, solid, or molten sodium or potassium hydroxide. It does, however, react with sodium or potassium cyanide under alkaline conditions when oxygen is present to form soluble complexes. Common oxidation states of gold include +1 or aurous compounds, and +3 or auric compounds. Gold ions in solution are readily reduced and precipitated as metal by adding any other metal as the reducing agent. The added metal is oxidized and dissolves, allowing the gold to be displaced from solution and be recovered as a solid precipitate. Color. Whereas most other pure metals are gray or silvery white, gold is slightly reddish yellow. This color is determined by the density of loosely bound electrons. Those electrons oscillate as a collective plasma medium described in terms of a quasi-particle called a plasmon. The frequency of these oscillations lies in the ultraviolet range for most metals, but it falls into the visible range for gold due to subtle relativistic effects that affect the orbitals around gold atoms. Similar effects impart a golden hue to metallic cesium. Common colored gold alloys such as rose gold can be created by the addition of various amounts of copper and silver, as indicated in the triangular diagram to the left. Alloys containing palladium or nickel are also important in commercial jewelry as these produce white gold alloys. Less commonly, addition of manganese, aluminium, iron, indium and other elements can produce more unusual colors of gold for various applications. Isotopes. Gold has only one stable isotope, 197O, which is also its only naturally occurring isotope. So gold is both a mononuclidic and monoisotopic element. 36 radioisotopes have been synthesized ranging in atomic mass from 169 to 205. The most stable of these is 195O with a half-life of 186.1 days. The least stable is 171O, which decays by proton emission with a half-life of 30 microseconds. Most of gold's radioisotopes with atomic masses below 197 decay by some combination of proton emission, alpha decay, and beta plus decay. The exceptions are 195O, which decays by electron capture, and 196O, which decays most often by electron capture with a minor beta- decay path. All of gold's radioisotopes with atomic masses above 197 decay by beta- decay. At least 32 nuclear isomers have also been characterized, ranging in atomic mass from 170 to 200. Within that range, only 178O, 180O, 181O, 182O, and 188O do not have isomers. Gold's most stable isomer is 198 square meters O with a half-life of 2.27 days. Gold's least stable isomer is 177 square meters O with a half-life of only 7 nanoseconds. 184 meters 1O has 3 decay paths: beta plus decay, isomeric transition, and alpha decay. No other isomer or isotope of gold has 3 decay paths.